Whenever you guys are ready, can you talk me through what you've built?
Sure. So this is our Tennis for Two game. It gets displayed on the oscilloscope, and it's based off of, I think it's the second video game to ever exist. It was created at one of the labs a while ago. So just kind of starting off the game, one player will press the button, and whatever player presses the button will be the person who will serve for the game.
Okay.
So Jack pressed the button, so player one, who is going to be on the left side, starts off the game.
And let me just show that you're using this little controller that you've put together, which includes a button and a knob, and then you have a similar button and knob. Okay. So your screen for the video game is an oscilloscope in XY mode.
Yeah. So
whenever it goes regular tennis scoring, and whenever one person wins, then it goes back to this like loading screen.
So okay, so this is your
This is like the start screen.
waiting for input screen.
And whoever presses the input first, so if we press it here, then it becomes player two serve.
Okay. And I'm just gonna, so when you twist that knob,
yeah.
what happens here?
So kind of like at the top of the knob is going to be like your greatest angle. So if I press this here, I think it launches kind of at like a 45, 50 degree angle relative to kind of like a normal position.
Sure.
And then if you were to like turn the knob all the way down, it would be kind of the same in the same direction. So essentially you kind of have like 90 degrees of flexibility in what you're able to
Sure.
angle the ball off of. So like angling down is pretty useful when you're at the net, kind of like a volley or an overhead.
Okay.
And when you're back, it's usually better to have a higher angle to be able to clear the net.
And am I correct? So when you push the button, that's how you strike the ball to the other, and you can push that button at any point when the ball is in flight?
Only when it's like on your half of the...
When it's on your half of the court, okay.
Also, we made it so it only works if it's below this line. Otherwise, you could just keep hitting it back and forth and it goes off the
Oh, sure. Okay. Okay.
And you know, tennis player is only so tall.
Yeah, sure. That is really neat. Can you play maybe one more volley?
Yeah. So if we volley it at the net, yeah, you kind of like spike the ball there. Like,
We also-
like that one out of bounds.
It's hard to demonstrate, but we also have, if it hits the net right at the top, it does that thing in tennis where it like clips through barely.
Really?
So where I get that.
Oh, wow. Yeah.
He gets the point there.
We also have just like the physics off the net too, so it'll bounce.
Yeah, if it bounces off the net, it like damps a lot. It slows down the speed by like 50%, I think, when it hits the net.
Wow. Kind of rolls back. And then scores being maintained with these LEDs?
Yeah.
Yeah.
And we have it similar to tennis where you have to win by like 2 points. So
Okay.
if both players get to 3 LEDs, it will decrement both win by 1.
So then 2 of them are lit up to indicate a deuce.
That is really neat. And this is this a potentiometer?
Yeah, it's a 10K.
A 10K potentiometer and then a push button. Very cool. I'm just going to demonstrate that when I push the button, the ball flies. So you are implementing a video game on an oscilloscope in XY mode. Can you talk a little bit about how you draw the net and then how you draw the ball?
Sure. So the net and ground are both drawn. Essentially, we have 2 interrupt service routines, one for drawing the net, one for drawing the ball.
Okay.
The one that draws the net and ground runs at, I think, a pretty low frequency, but it draws a lot of points that are basically just along the ground here, running through just a for loop, basically. And then the same thing for the net, just to draw a vertical line here. And the other ISR draws the ball at whatever the position that's determined by the thread is. And that is a much higher frequency, I think, so that the ball runs at a nice full
Sure. And maybe we should clarify too that when you say draw, the way that you're drawing is with a DAC, correct?
Yeah, so to draw, it sets the voltages on the pins that go to the DAC. And
Okay.
then the DAC converts that to an analog signal, or an analog DC voltage that goes to the oscilloscope.
I'll just show that up here. Yeah, so here's your DAC. So it's a 2-channel DAC. So you can set 2 voltages. The scope is plugged into one of the outputs of the DAC and the other output of the DAC, and one controls the X position of the cursor, the other controls the Y position of the cursor.
Yeah.
That's so cool.
And then our loading screen too. At the beginning, we were playing around with DDS a little bit. So the ball that's circling around is actually like the DDS algorithm, so you get a perfect circle as it's loading. I just missed it. If we go back to that.
So here's the loading screen.
Yeah, so that's 2 sine waves 90 degrees out of phase on the X and Y channels, and running at a fairly low frequency so you can see it drawing instead of just being a solid circle.
That is really, really neat. Really, this is the first video game I've ever seen implemented on an oscilloscope. It's very cool. Is the gameplay based on the original Tennis for Two game, as far as you know?
Yeah.
We followed it as closely
As you could sort of determine.
yeah, just based on watching videos.
Okay. It's really neat. Awesome. Thank you both. That's a really cool demo.